Um, so, Evelyn, I do not have any suggestions for alternatives. I can give you an extension on the first quiz. However, I guess I would say, I would suggest also just asking this question in the week one discussion, because I have a hunch some of your classmates may have some ideas about that. But I unfortunately do not. Okay, so I'm going to share my screen.
Yeah, are you using the same book from CS10C last semester that you used? Because I still have the PDF for free. Because I remember it was hosted on a website last semester, but I think it got taken down. The textbook for free.
We are still using the same textbook, yes.
Okay, so I'll just email you a link for it for free for anyone who doesn't.
You should probably not tell me about that.
Oh, okay, gotcha.
Let's see, desktop. Okay, so what I have here, you guys are seeing a bunch of windows now, right? Actually, there's one thing I want to do. Okay. So you guys can see my myvector.h and myvector.cpp windows. Is that correct? Okay. And I apologize about the size of the text, and I have not figured out a way to make it bigger. If that's a problem for anyone, let me know, and I can work harder at figuring out a solution. I can just pop it into Word or something. But, okay, so what we're going to do here is basically I have a vector class that is exactly like the standard template library vector class, except it can only handle vectors whose elements are of type int, right? So if you look right here, you're going to see I've declared this variable called value type, and value type is simply an int. Okay. So what I'm going to do is I'm going to take you through the process of turning this regular class, which we can use to represent vectors of type int, vectors with elements of type int. We're going to convert that into a templated class so that we can use it to store vectors with any type of element. Okay, and that's a pretty straightforward process. This is not like one of those big conceptual things. We'll do that in a couple of weeks, and we'll do recursion. Okay, there you've got like no syntax, but a lot of big heady concepts. This is more just like, okay, plow your way through these steps and just do it really carefully, because the syntax gets a little messy, and if you mess something up, it can be really hard to find the bug. So let's see, I just have a few observations about this class that I have here. The first one is, I don't remember, I guess we didn't talk about value type last time. But basically the idea is, instead of just using int everywhere throughout the class, I'm going to be using value type everywhere throughout the class. Bunch of mic feedback. Is that mine?
Yeah.
Yeah, it's pretty distracting.
I have no idea what to do about it. Oh, is it still doing it?
There we go. That's a little bit better.
It's a lot better.
I actually think my air conditioner may have just turned off. That may be what was going on. Anyway, we'll try this. Command plus work to increase font size. I'm almost positive it does not, but I will try. Command. Yeah. It's a text editor. So I have not been able to figure out if there's a way to increase the font size, and I suspect that there's not. Okay, so back to value size. I'm not sure if this is going to work. Makes sense what I was saying about value size? It's a little bit like a constant is to a variable, right? So for a long time, since the beginning of TIS 10a, we've been declaring constants so that if something changes in the program and this number occurs like 1,000 times in the program, we don't have to change all 1,000 occurrences. We can just change the value of the constant at the top. That should sound familiar. This is the same idea, except now we're doing it with types. Okay, so if I wanted to make this my vector class store strings instead of ints, I would just have to change this word right here, int, to string, and I'd be done. Any questions about value type? The other reason for doing that is that that's also another STL thing. Every container class in the STL has a type called a value type. So you can always use that if you need to for some reason. Okay, next observation. So we've got a constructor, we've got a size function, we've got a capacity function, we've got an at function, and we've got a pushback function. So that's what, 5 functions? So if you look at the definitions of these functions, you've got, here's the constructor. It's pretty straightforward, right? We're setting M size and M capacity. So in this case, M is the prefix I'm putting on the data members of the class, so I can distinguish them from variables that aren't data members. Items is the array that we're going to store the elements in. And so we're starting it off being equal to whatever the size was. And then we've got a for loop that is going to set all of the elements equal to this second parameter. Let's see, and I think in my header file, I used default parameters, right? Right, so if I leave off the second argument when I declare a vector, it's going to fill up all of the elements with whatever the default is for value type. There's a lot going on there. Makes sense? Anyone want to ask a question about that? So for example, in this case, I'll just keep babbling for a minute, I guess. In this case, value type is int, right? So it turns out that if I say int, open paren, close paren, what that's going to do is it's going to give me whatever the default value of int is, which turns out to be 0. Okay, so in this particular case, since the value type is int, the default value for the second parameter is 0. Everyone remember about default values? Might need to, let's see, in my lessons, I covered that, gosh, I don't remember, to be honest. I think lesson 16, when we talk about operator overload. Yes, initialize to 0. Yeah. Yes, that's correct. Okay. So that's the constructor. The size function's trivial. The capacity function is trivial. The at function just returns item sub I, whatever the parameter is. So I don't want to use the word trivial, but if it's not clear what's going on in the at function, let's talk about it some more. So let me know. And basically that's the square brackets operator, right? We're using that to get the value stored at a particular index in the vector. Probably what I should have done is I probably should have shown you the client code first. Too late now. Let's talk about the pushback function for a second. Sorry, stepping back just for a second, in case it's not clear, what we're doing here is I haven't started talking yet about the process of converting this to a templated function. We're just spending some time taking a look at this original, I said templated function, templated class. We're just taking some time to look at this templated, at this regular, not templated class, so that we get familiar with it, so that we're then going to be ready to convert it into a templated class. Okay, so pushback, basically, if the size is less than the capacity, then we're fine, right? We just put the new item at the end of the array and then increase the size by 1. Done. All of this here is what we have to do if we are trying to push, we call push back when there's no more room in the vector. In other words, the size is not less than the capacity, right? So in that case, we're gonna increase the capacity. Okay, so if the capacity is 0, we're gonna make it 1, otherwise we're gonna double it. Then we're going to create a new dynamic array of size capacity. Then we're going to copy the old array into this new temporary dynamic array. Then we're going to add the new value to the end, increment the size, delete the old array, and then just make the items data member, which used to point to the old array, point to the new array that we created. Okie doke. Any questions about any of that? Okay, I'm just kind of guessing that some of you may be looking at this and going, wait a minute, those are arrays. How can you do that with an array? So I guess what I'm going to say there is just remember that arrays are also pointers. So all I'm doing there is making one pointer point to the same thing that another pointer is pointing at. And if it would help for me to draw a picture of that, maybe we can do that like at the end of class or something. Just ask me and we can do that. Okay, I think I am done introducing this myVector class. Let's take a look at the client. This is pretty much exactly the same client we wrote when I was just introducing you to the STL vector class. We're just declaring a vector. I just changed, the only thing I changed is I changed vector, open bracket, int, close bracket to myVector. We're declaring a variable for current size. We're pushing back, we're calling the pushback function 20 times to fill up the vector, and then we're printing the vector. All right, let me see here. So this is actually something new that I should have mentioned. earlier on Tuesday, we talked about using size type when it has been defined inside an STL class. What we're doing here is now we're on the other side of that, right? We are writing the STL class, sort of. And so we're going to provide a type called size type. And this is how we define it. Okay, we're going to use std : size _ t. That is a variable, that's a type that is defined on every system that is guaranteed to be able to hold an integer big enough to represent the size of any container stored on that system. So if that didn't make any sense at all, you're still fine. I wouldn't worry about it too much. You just may have to remember, if I say that you have to have a size type in your class, you're just going to copy and paste this exact line right here and you're done. All right, everyone ready to convert this thing into a templated class? Sorry, the position of my computer is not working. Let me try again. Problem is, I'm using an external keyboard because my laptop keyboard is broken, so these are a little complicated. Okay, any questions before we dive in? I'm going to take you through 6 steps for converting a non-templated class into a templated class. Step 1. Actually, let me, just so you can actually read this, let me pull up the lesson. Sometimes it helps people to actually be able to see what I'm saying in print. So, lesson 19. Okay, so can you see this line at the very bottom of the screen that says step 1? Step 1 is place the template prefix before the class declaration and before each member function definition that occurs outside the class declaration. Okay, so let's go ahead and do that. Place the template prefix before the class declaration, so that would be right here. Type on my broken keyboard. Template class T. By the way, on the template, call it template prefix, there are different ways to do this. Using a capital T to represent the type there's a very strong, long-standing convention for using uppercase T for that. Some textbooks, I think maybe even our textbook, have realized that, you know, we always say don't use one-letter identifiers, right? So maybe we should use something a little more descriptive for that, and that's fine. And then the other thing is that this word class here can also be something else. And I'm actually spacing on what the other option is at this point. But I wouldn't worry about it because, you know, there's a pretty, type name, thank you. There's a pretty strong convention and history of using the word class there. If you want to use type name instead, that's fine, but I just use class. There will be another use of type name that we will have to use. Okay, so basically this is the template prefix, and I have to put this in front of the class declaration and also in front of every function definition that does not occur inside the class declaration. So that would be the constructor, size function, switchback function, the capacity function, the at function, and that's it. You can probably tell that I'm struggling with using my real estate effectively here. Trying to make it so you can see both of these files at the same time. Okay, there's step one. Pretty straightforward. Any questions about step one? All right, let's go back to the notes. Step two, place angle brackets T after each occurrence of the class name that occurs outside the class declaration. The only tricky part to that is that there's one time when the word my vector is going to appear, but it's not actually the class name. So we're looking for the word my vector outside the class declaration. So here's the first one. Now let's look at this one. My vector here, the problem there is that that's not actually the name of the class there in that position. In that position, that is the name of the function. So in that case, we are not going to put the angle brackets T after it. All right, so let's keep going. My vector T, my vector, whoa, that didn't work. T. Any questions about what I'm doing here? My vector T. My vector T. My vector T.
So basically, you just put in T in every my vector after any my vector.
Yes, that's exactly right, except I don't do it when it's the name of a function. I do it when it's referring to the class. So yeah, we'll get there in a sec, Kaylin.
Okay.
Yeah, every time you see my vector, and basically the only case, I'm pretty sure the only time you're ever going to see the word my vector and it's not the name of the class is when it's the name of the constructor. Other than that, you're going to put angle brackets T after each occurrence of the word my vector. Another way of saying what's going on there is, so basically what we're saying now is there's no such type as my vector. Anytime you want to use the type, you have to say my vector with angle brackets after it. If you just say my vector by itself, the compiler is going to say, oh, there's no such type as my vector. Any questions about that? Okay. Step 3. Replace each occurrence of the original type with the letter T, or whatever you called your type parameter. So if we hadn't used a value type, that would mean that we were going through all of our code and the entire class looking for the type int when that type int is referring to the type of the elements in the vector. And we're changing all of those ints into T. As it turns out, since we used a value type, we can just keep using value type all the way throughout our code. And all we need to do is just change this one int right here to an uppercase T. Okay, so what we're saying now is when the client programmer uses the myVector class, declares an object of type myVector, they're going to put something in angle brackets after the word my vector. So let's just talk about that for a second. This is a little bit of a digression, but I want to make sure that you understand what is going on behind the scenes here. So if we go back to the client, basically what we're going to do now that my vector is a templated class, instead of just saying my vector, we're going to say something like my vector int, right? And so when the class sees that, the class is going to go, okay, that means that T is representing int. So every time in the class that I see the uppercase T, I'm going to use int instead. And then of course I could, go next time I declare my vector, I could make that a string instead of int. And that would mean that I would have, every time I see a T, I'm going to treat it as a string. But sticking with int for now, what that means is that right here, that's going to basically be int. And so we're defining value type to be int. And so all throughout our code, whenever we use a value type, like here and here, that's really going to be int. Any questions about that? All right, we are done with 3 out of the 4 steps. Step 4. Down a little ways. Step 4. Outside of the scope of the class, so anywhere in our code of this class that we are actually not in the scope of the class, we're going to have to add the keyword type name before any occurrence of one of the types that are defined in the class. That was a really long, complicated sentence, but the concept is not that hard. Let me just show you a couple examples. So this part's a little tricky, but let's look at the capacity function. Wait, that's not a, yeah. And let's look at the size type, okay? Size type is one of the types that is declared in the class. The question is this inside the scope of the class or not? Turns out, and then actually maybe this is even a better example. Let's look at the at function. Here I've got value type. That's a type that was declared inside the class. And here I've got size type. That's also a type that was declared inside the class. Turns out that this occurrence of the type is outside the scope of the class. But by the time we get here, the compiler already knows that we are inside the scope of the class because there's the scope resolution operator, right? So I do not need, this rule, step 4, doesn't apply to this occurrence because that's inside the scope of the class. But it is going to apply to this occurrence because that's outside the scope of the class. Any questions about that? All right, I guess that's good. Actually, in practice, it turns out to be even simpler than that. There may be some situations that I have never come across, but in my experience, the only example of types that meet the criteria for this step are when the return type of a member function is a type that's declared inside the class. So basically, I'm telling you that for this class at least, and I have a hunch maybe this is always true, the only time you're ever going to have to use this rule is, let me rephrase that. When you're applying this rule, all you're going to need to do is look for return types, and that's all you need to look at. So the rule was put the word type name in front of each occurrence. Okay, just like that. Here's another one, size type. I'm going to put the word type name in front. This is void, so that's not going to apply there. Here's another one, size type. And I think that's it. All right. You guys still there? Okay. In trying to manage my real estate, I have minimized the window with all the faces, so feels like I am talking to nobody. All right, any questions about step 4?
No, all good, I think.
Awesome. All right, step 5. Honestly, step 5 is the one that trips people up the most. So here we go. Don't compile the implementation file separately. So this requires a little bit of understanding of what's going on with compiling and linking, which is something that we probably haven't talked as much about as maybe we should have. But you know, when you run, let's say you're using an IDE, and you've got your typically what we say is put your implementation file in your project and put your client file in your project. What's going on there is the compiler is going to compile the client file, and then completely independently, it's going to compile the implementation file. And then it's going to link those two files together to create the executable file. Everyone okay so far? I will take that as a yes. When you use templates, the compiler cannot compile the template until it knows what the type is that the client program is going to ask for. So you cannot compile the implementation file separately from the client file anymore. So what we do instead, let's see. When you have a project that includes a templated class, the compiler can't compile the code until it knows what the type parameter is going to be. For this reason, we can't compile the implementation file separately from the client code the way we have done in the past. Instead, from the compiler's perspective, the code all needs to be in one big file. So instead of compiling the implementation file separately, we will be including the implementation file from the bottom of the header file. So here's step 5 in more detail. First, delete the #include of the header file from the top of the implementation file. Because the header file is already going to be included by the client programmer. Step 2, add a #include of the implementation file at the bottom of the header file after the close of the namespace block, if you are using namespaces. So I guess I should actually just do those while we're at it. So I'm going to delete the #include from the top of the implementation file. So that's this right here. Everyone see what I'm deleting? Okay. Then step 2 is at the bottom of the header file, I'm going to say #include myvector.cpp. Okay. So now basically what's going on here is the client program still includes myvector.h, and myvector.h at the bottom is just going to tack on myvector.cpp to the bottom, so it looks to the compiler as if this is all one big file. Next, this is the part that everyone forgets and gets stuck for hours trying to debug. You have to remove the implementation file from your project. Otherwise, the IDE is still going to be trying to compile that implementation file, and you're going to get a bunch of error messages. So in my case, I'm not using an IDE, so it's hard to demonstrate that. But I think everyone knows what I mean, right? You're going to have to go into your IDE, right-click on the implementation file and choose remove from project or whatever it is in your IDE. Just looking at your pictures so I know you're still there and alive. Oops. Last step, eliminate any using directives in the implementation file. The implementation file is now part of the header file, and we don't want using directives in the header file. Okay, what I really want to do here is I want everybody to raise your hand who understands why we don't want a using directive in a header file. I was actually meant like the Zoom hand, but okay, that's 1, 2. So I guess, well, I'm still figuring this out. I guess, George, you must have raised your hand and then put it back down again. So it's not showing up in my participants window, but all right. Well, either most of you don't know the answer to that question, or everyone's being bashful or sleeping. But that tells me I should talk about that a little bit. Okay, so notice in our original vector file, I have using namespace std here in the implementation file, but I don't have it in the header file. And instead, I just used the namespace prefix every time I had to, which was only once, I guess, in this case, but could be more. So if you, oops, if you say using namespace std up here at the top of your header file, then when the client program # includes the header file, that means that the client program, perhaps unknowingly, is now using that namespace, whether they want to or not. And that might actually break the program, right? Perhaps the client program is not using that particular namespace, and having it work correctly depends on it not using that particular namespace. So, in summary, what we're going to do, I mean, I suppose in one sense, if you don't understand any of that, you're probably okay. Just follow the steps, right? We're going to remove this using namespace std from the implementation file. And then we're going to find any place in this implementation file where we need that. And we're going to put std : in front. Doesn't look like there's many. There doesn't look like there's any of those unless I'm missing something. Oh, assert might be. Hold on a sec. Let me see what my notes say. Yeah, I think in our particular case, we lucked out because there are no there's nothing that's declared inside the STD namespace, apparently, unless I'm missing something. Okay, so for example, if we had say a print function in our class and we were printing to cout, then we would have to put the std : in front of the cout or in front of the indel. Or if we were using iStream or OStream, we'd have to put the std : in front of those. In this case, there aren't any. Okay, so that's step 5. Yes, Patricia, that is the same thing. It's just that using namespace std means that if you have that at the top of your file, that means that automatically, whether you want to or not, you are using namespace std every time in the rest of this file. So when we do the std : it means just on this particular occurrence. Okay, back to our steps. Step 6. Some compilers require default parameters to be in both the prototype and the function, typo, implementation. I have not actually found a compiler like that. I'm just putting step 6 in there because, that's what all the textbooks say. So my advice is don't worry too much about step 6 unless your compiler starts complaining. All right, let's take a look at our code here. I think we're good. I guess I shouldn't say I think. As far as I know, we're good. Probably when I run it, there'll be something I got wrong, but let's look at our client. Is there anything we need to change here? As I said before, once I'm using a templated class, there's now no longer a such type as my vector. So every time I see my vector, I'm going to have to put angle brackets afterwards. All right, anybody see any problems? Should I give this a try? All right, so unfortunately my computer doesn't have enough hard drive space on it to install Xcode, so I'm stuck using the console window, otherwise known as terminal in Mac. So let's see. So if this was not a templated class, I would have to compile both my client file and my implementation file separately. So I would type this. Okay. So this is, remember that step 5C that I said everyone always forgets. The way that gets implemented when you're using an IDE is you remove the implementation file from the project, or at least somehow prevent it from being included in the compile. How that works itself out on the command line that I'm using is I just don't compile it. Oops. Okay, so I'm just compiling the client and that's it. Let's see how many errors we get. Only one error. Inside my print function. Not even inside the definition, just inside the prototype. Try again. There we go. There's my output. Any questions? Wow, you guys are too easy. I heard something. By the way, totally fine whether you want to shout out a question or whether you want to type it in chat. Either way is fine. Okay, there's something I want to do for fun, and that is let's have a my vector of strings. I just happen to have some code here, if I'm not mistaken. Oh, maybe I don't. I thought I did. Never mind. The problem with just doing this on the fly, doing an int. Do I have that up here? All right, I'm not going to take the time to do it. I'm just going to tell you that it would be fun to add some code to our client program here that actually created a vector of type string and printed them out. A little bit tricky because we have to figure out how exactly to generate whatever the strings are that we're going to be putting into the vector. But anyway, you guys get the point, I think. All right, any questions about that process? Converting a regular non-templated class into a templated class. All right.
Nope.
Yeah.
I was just saying nope. Thanks.
Oh, okay. I thought you said hello. Kaylin, I am not in the habit of using a make tool, actually. Most of the stuff I do is too simple. Okay. Going back and looking at our notes, the next section in the lesson is going to be called Defining Iterator and Const Iterator. And so basically what this is it's taking this templated class that we just created, and it's adding an iterator class to the class, and it's adding a const iterator class as a subclass inside the class. As you know, or as we talked about last time, every class in the standard template library has a type named iterator defined inside it, and also a type named const iterator defined inside it. And so this is just showing how you might do that. You are not responsible for this, but I left it in here because I thought it might be interesting. And also sometimes when you see how something is working behind the scenes, that can help you understand how it's intended to be used on the outside. So here's basically inside my vector class, I have a class called iterator. It's right here. Because when you've got nested classes, the syntax can get really messy really fast. Instead of declaring our functions inside the class and then defining them outside the class, we're just throwing everything in right here. So I've got a constructor, I've got the star operator, which if you've worked on, well, I should say when you work on assignment 1.1, you'll be using the star operator. You'll be using the plus plus operator that advances the iterator, and so on. Okay, I'm not going to go over this in a lot of detail right now. It's there in case you want to take a look at it, and I think it'd be worth taking some time to make that make sense. Okay. Next, I have a little mark here that I need to, that's two things in the lesson that I need to fix. Okay, we need to talk about exception handling. I am just going to cover it really fast, and probably most of what you will need exception handling for in this class will be covered by what I'm going to tell you very quickly. There's a lot more to exception handling. I would encourage you to read about it in the C++ interlude in the textbook. If you've still got the textbook from CS 10A and 10B, they have a chapter on exception handling that's pretty good too. But I'm just kind of giving you the minimum that we need to get by for now. All right, so exception handling is a way to handle errors that's more sophisticated than what we have used up to this point. Basically, up until this point, we've pretty much just used assert, I think, which just basically says, crash the program. In our MyVector class, if the client tries to access a MyVector index that is out of bounds, we simply abort the program using the assert. With exception handling, we can send information back to the client and let the client decide how to handle the error. This action by the class is called throwing an exception, and then the client is responsible for catching the exception. So the fundamental rule in C++ for exceptions is that when you throw an exception, what you're actually throwing is an object, or another way of saying that is what you're actually throwing is just a variable. So the simplest form of exception handling is when the object thrown is something simple like an int or a string. That's rarely done in practice, but we're going to just start there because it's a good, simple place to start learning about exception handling. And so here's how we would rewrite our at function to utilize exception handling in this manner. So I'm just going to say if the index is out of range, then I'm going to create a string, assign it to out of range error, and then I'm going to throw, excuse me, I'm going to throw string. If that's not the case, if my index is fine, then I return item sub I like before. Simple enough. Any questions about that syntax? Basically, only new thing so far is just the word throw, right? Okay, I think that's pretty straightforward. On the client side, the client's going to have to catch the exception. So what we do there is we have to have what's called a try catch block. So here's what that would look like. For example, in my print function, I put my loop that is calling the at function inside a try block. And then after the close curly brace on the try block, I have the word catch. And then I have this weird thing here that actually looks sort of like a parameter, right? I mean, I've got the word catch here and almost looks as if catch is a function with one parameter. So the syntax is similar to that on purpose because it's a similar idea, but it's different, obviously. Catch is a keyword, and it just means that if inside the try block, an exception is thrown, and the type of that exception, remember when you throw something, it's a variable, so it has a type. If the type of that thing that was thrown is a string, then this catch block will catch that exception. And it just means that the execution goes from inside the at function directly to right here inside the catch, and it skips everything else in the try block. Okay, and so instead of just sort of halting the program and starting over, I can just choose, as the client programmer, I can just choose to print out an error message and move on. Okay. Any questions about what's going on there? Okay. One of the fundamental things, well, actually, let me just say, right, this isn't very interesting because in this particular example, the index never goes out of range. So in order to actually get to see this work, and I hope you don't mind, just in the interest of time, I'm not going to actually plug this into my files and execute. I would actually recommend that you experiment with that yourself. You know, copy and paste this code and try it out. But I'm just going to show you what happened when I ran it before, right? In my try block, instead of printing the whole vector, I'm just going to say print me dot at 30, which is out of range. And so what's going to happen is I'm going to fill out my vector just fine. And when I go to the print function, it's just going to print error, my vector index out of range, because the at function threw an error message. Okay. Any questions so far? One of the fundamental things about exception handling that I'm not going to, that is not in my lesson, that I'm just going to mention briefly, is that, I don't think it's in here anyway. You could have different kinds, you could have a series of catch blocks, right? So I could say catch string E, and I could say catch int E. So in case the at function threw an exception that was of type int, it would not catch it with this catch block, but it would catch it with a catch block down further that caught exceptions of type int. And you can have as many of those catch blocks as you want, catching all different types of exceptions that get thrown. All right, let's move on. There's more stuff I could say about this, but I think it'll be better to look at what's coming up next. All right, so in this example, instead of my print function saying cout my vector index out of range, it's going to actually print the value of that string that was thrown. So for example, the at function, maybe sometimes it throws a string that says index out of range. Other times it might throw an exception that says, blanking on what other kinds of errors there might be, but some other kind of error. You know, maybe a memory overflow error, something like that. So then when in my print function, when I print my error message, I get to print the correct error because it was thrown to me by the at function. Okay, any questions about this so far? Only thing left to do is we're going to actually talk about how this is really done in practice, and that is that the class programmer is going to define a class whose only purpose is to be an exception that can be thrown. Okay, so here's my an abbreviated version of my vector class. And here, just first thing in the class, I just declared a new class called out of range error, open curly brace, close curly brace, nothing inside the class. It's not going to do anything at all except just be a new type that can be thrown. So then in my at function, I don't know why I'm missing the if statement here. That's funny. So I'm going to throw out of range error every time, no matter what I is. That's the third thing I need to fix about this lesson, right? So this should really say, if I is less than 0 or greater than or equal to m size, throw out of range error. Any questions about that statement? This is something I'm not sure you've seen a lot of, but we're going to see more of it. It's I am creating an out of range error object on the fly here. I'm calling the default constructor because I've got open closed paren right next to it, so it's the default constructor. And then that object is what's going to be thrown. So back here in my print function, my catch now, the type of the exception is going to be out of range error, which is that type that I defined. And here I caught it and printed my vector index out of range. There's other things you can do with this. For example, you could have the out of range error class might have a data member that's of type string, so that you could so that inside your at function, before you throw it, you could assign the data member to be equal to something, so that the client programmer could then check to see more information about the error that was thrown, right? So you can set it up so that when exceptions are thrown, they provide more information other than just what the type of the exception is. That's a good question. You can do that, and that's fine. It's if things are as simple as they are here, which they're often going to be in this class, it's not really necessary. So I'm going to leave it at that. All right, I'm at the bottom of the page. Anybody have any questions about anything we've done today? One of the things that I'm going to try to do this semester is I'm going to try to have us use exception handling more than I have the last couple of times I taught the class. That's one of the reasons why I haven't posted assignment 2 yet. I want to have a chance to kind of work on it a little bit. At least I don't think of it. I have. Oh, I have posted them. So maybe what I should be saying is don't work too far ahead, because I may be making some changes. I think assignment 2 is good, but assignment 3, I'm going to try to add some exception handling in there that wasn't in there before. All right, that was completely random information that you probably didn't need to know. No questions? Everyone's ready to start working on the assignment and get it done by Monday. Hopefully it won't be too much, too difficult. Just keep us posted.
Yeah, all good.
All right. I will see you guys next Tuesday, and hopefully this time I won't have an appointment that I forget about until the last minute.
Oh, someone wants to know a little more about the homework.
Oh, thank you for pointing that out. I'm happy to explain a little more about the homework. Did you have like anything in particular, like which part you're wondering about, or just want me to babble for a couple minutes?
Yeah, it's more something general, so we can understand a little bit more about what we can do with the homework, or what we have to do with the homework.
Okay, so there's 2 parts. The first part is having you do some practice with iterators. So it's basically you're going to be, I'm giving you a program.
Are you intending to share your screen, Dave, by chance? Because you're not
yes,
sharing.
I stopped. Yeah, thank you for reminding me. I forgot that I had stopped doing that. Share. So the first part is having you practice with iterators. So I have provided a program written using arrays. Your job is to translate this into exactly the same program with exactly the same functions and exactly the same steps, except you're going to be using a vector instead of an array. And you're going to be using iterators to iterate through the vector instead of using indexing. I don't think that should be too hard. I think, it's pretty much exactly the same thing that I showed you in lecture. We we had a client program using a vector, and I had a for loop that used indexing, and I changed it to using iterators. So
What we saw on Tuesday, right?
yes, exactly. Yeah.
Okay.
And then part 2 is just exactly what we did today. You're going to do exactly the same thing I did today. I'm giving you this class to start with, and you are going to convert that into a templated class. And that's pretty much it. And then I also think I tell you that you have to add an exception, a little bit of exception handling to the class. But that's it. Is that good enough for now? All right.
Yeah. Okay. Thank you.
Right. That's a good point, Kelly.
Thanks for class.
Yeah.
Yeah, thanks.
I did just want to mention about the auto keyword. I'm not sure what the question was in reference to, but I'm going to say, until I tell you otherwise, I'm going to ask you to not use the auto keyword, not because there's anything wrong with it, but because we're students in a class, I'm going to want to actually have you practice knowing what the types are that need to be there in your code. Basically, for those of you who don't know, the auto keyword is just, the auto keyword is something that you can use instead of putting the type of something if it's in a context where the compiler can figure out what the type is supposed to be. The reason for it is that, as we're going to see over the next few weeks, our types are going to start getting really long. Like you could have, instead of int being the type, your type might actually go halfway across the screen or more even. So it can get a little tedious sometimes. All right, I think that's a good sign that it's time for us to stop. All right, I'll see you guys next Tuesday.
Sounds good. Thank you so much.
Thank you very much.